Hi, GSIS student. This is the first lecture of fourth week of statistics. Today, I'm going to talk about probability. This is what we learned last week. First, I explained numerical descriptive statistics, measure of central location, measure of variability, measure of relative standing, measure of linear relationship. For measure of central location, I introduced three measures: mean, median, mode. Mostly, you are going to use mean, but mean, median, mode, when you use it, the best choice is depending on situation. Okay, so you should know what situation you have to use one of these measures. And then another measure of variability, I introduced range, standard deviation, and variance. Actually, measure of variability is one of the most important parts in statistics. We cannot describe data with the measure of central location. So always you should include measures of variability. Generally, we are going to use for measure of variability, variance or standard deviation mostly. For measures of relative standing, I introduced percentiles, quartiles, and box plot. And also, I explained box plot with some example. It's a very useful technique. Then I introduced measures of linear relationship, covariance, correlation. In social science, like management department, you are going to use a lot of example with correlation and covariance. So everybody in this class should fully understand what is covariance, correlation, how to calculate, and how to apply. Then I introduced how to assign probability and probability concept, event, and relationship between event and joint, marginal, and conditional probability. Then I introduced probability rule, especially complement rule and multiplication rules. And today I'm going to introduce first probability rules with the addition rule. Then I'm going to explain probability tree, then Bayes law. Let's see addition rules. The addition rule is used to compute probability event A or B or both A or B occurring. That is the union of A and B. Probability A union B is equal to probability A union B is equal to probability A probability B minus probability A intersection B. As you can see, this is a probability A union B, then probability A plus probability B and minus intersection. But if A and B are mutually exclusive, then its term goes to 0. With the example, I'm going to explain addition rule. In a large city, two newspapers are published, the Sun and the Post. The circulation department report that 22% of the city's households have subscription to the Sun and 35% subscribe to the Post. A survey reveals that 6% of all households subscribe to both newspapers. What proportion of the city's households subscribe to either newspaper? That is, what is the probability of selecting household at random that subscribe to the Sun or the Post or both? The question is, what is probability Sun, Union, Post? Think about how to calculate probability Sun, Union, Post. In this problem, we are interested in probability Sun, Union, Post. So we have to use 22%. 22% of the city's household have subscription to the Sun. 35% Post, and 6% of households subscribe to both newspaper. Using this statement, probability Sun, Union, Post is equal to probability Sun plus probability Post minus probability Sun and Post. And this is addition rule. Then it's 0.22 plus 0.35 minus 0.06. Then is equal to 0.51. So there is a 51% probability that randomly selected household subscribe to one or the other or both papers. So do you understand how to apply addition rule? You should fully understand. An effective and a simple method of probability an effective and simple method of applying the probability rule is the probability tree. In the probability tree, the event in an experiment are represented by line. The resulting figure resembles a tree. We will illustrate the probability tree with several examples, including two that we addressed using the probability rule alone. Look at last week's example of 6.5. In that example, we tried to select two women, two girls, students in 10 students. To know, so two students are female, then the probability over two student female can be calculated using probability tree. So this figure is called probability tree. First selection is 3 over 10. So this is a first event. Then this part is called second event. That is probability F. F means female, probability female. The probability of selecting a female student first is 3 over 10, first selection. And second selection is given a female, what is the probability of second selection is female. First is a female, second is a female, is 2 over 9. So first selection is 3 over 10, second selection is 2 over 9. Then what is the probability? FF. That is both female, probability female. How do we calculate this? Just a multiplication rule. Then let's see, next slide. At the end of the branch, we calculate the joint probability as the product of individual probability on the preceding branch. So then, you can see joint probability here. This is what we want to know part. But the other part we can calculate. The first selection is a male. Second selection is a female. So female male probability you can calculate it like this. For the other branch you can see what is the minimum of that, and then you can calculate. If you add all joint probability here, what is it? What is the answer if you add all of them? Think about that. It's equal to 1. Suppose we have our graduate class of 10 students again, but make the student sampling independent. That is with the replacement. A student could be picked first and picked again in second round. Our tree and joint probabilities now look like. Think about it and try to solve a problem. You can do it. So refer to this figure, then you can see the answer. Probability associated with any set of branch from one node must add up to 1. So this part, if you add 1, this one, 1, this one, 1, something like this, you can check easily, very easily. When you draw probability tree, check this part. There is no requirement that the branch splits be binary, nor that tree only goes 2 level deep, or that there be the same number of split at each subnode. Let's try to show this example. Law school graduate must pass a bar exam. Suppose pass rate for first-time test takers is 72%. They can rewrite if they fail, and 88% pass their second attempt. What is the probability that a randomly selected graduate pass the bar exam? A randomly graduate pass the bar exam. Try to answer this question. You can draw a probability tree because this is a example of probability tree. Draw a probability tree. Actually, for easy problem, if you don't draw a probability tree, you can solve the problem. However, if you draw a probability tree, then you can more easily solve the problem, or you can avoid the error. So, if possible, draw the probability tree. Try to solve the problem. Isn't it easy? Everybody got the answer? So let's see. this is the probability tree. Then the question is probability that randomly graduate student passed the bar exam. So this one, first pass, second pass, or first fail, second pass, right? Then you should add these two. Is that right? So the answer is probability pass is equal to probability pass first time and probability fail first time and second pass. Then it is 0.7 plus 0.2464. As I said before, so it is equal to 0.9664. That's the answer. Let's move to Bayes' law. Bayes' law is named for Thomas Bayes. He is an 18th century mathematician. In its most basic form, if we know probability B given A, we can apply Bayes' law to determine probability A given B. So probability B given A is equal to, if we know probability B given A, then we can calculate probability A given B. Let's see example from the next slide. Pay $500 for MBA prep. The graduate management admission test, the GMAT test, is a requirement for all applicants of MBA program. And there are a preparatory course designed to help improve GMAT score, which range from 200 to 800 score. Suppose that survey of MBA student reveals that among GMAT score above 650, 52% took a preparatory course, whereas among GMAT scores of less than 650, only 23% took preparatory course. An applicant to an MBA program has determined that he needs score of more than 650 to get into a certain MBA program, but he feels that his probability of getting that high score is quite low, 10%. He is considering taking prep course that costs $500. He is willing to do so only if his probability of achieving 650 or more doubles. What should he do? Think about how to solve previous problem. How can you attack this problem? What is your strategy to solve this problem? Generally, in this case, we should change English statement to kind of a sign or symbol, okay, like this. But event A is a GMAT score 650 or more. Hence, a complement is a GMAT score less than 650. Like this, you have to change English statement to symbol or sign. Then our student has determined the probability getting greater than 650 without any prep course as 10%. That is probability A is 0.1. It follows that probability A complement is 1 minus 0.1 is equal to 0.9. Like this, other part you can change this. Then you can apply Bayes' law. Let P represent event, take prep course, and thus probability PC is do not take the prep course. From our survey information, we are told that among GMAT scores above 650, 52% took prep course. That is probability B given A is a probability 0.52. Probability of finding a student who took the prep course given that they scored above 650. But our student wants to know probability A given B, that is, what is the probability of getting more than 650 given that prep course is taken. If this probability is a 0.2, he will spend $500 on the prep course. Among genius score of less than 650, only 23% took preparatory course. That is, probability B given a complement is 0.23. Probability of finding student who took prep course given that he or she scored less than 650. So, conditional probability B given A is 0.52. Probability B given A complement is 0.23. Again, using the complement rule, we find the following conditional probability. Probability B complement given A is 1 minus 0.52, 0.48. And probability B complement given A complement is 1 minus 0.23, 0.77. Here we are trying to determine probability A given B. Perhaps the definition of conditional probability from earlier will assist us. We are going to use this formula. Probability A given B is equal to probability A intersection B divided by probability B. You don't know probability A intersection B, and we don't know probability B. How do you calculate? How do you know? Perhaps if we construct probability tree. So last slide we are going to show you how to construct the probability tree. So we know probability B given A is 0.52. How do you get probability A given B? First probability A complement, then probability B given A. We know that. Then if you multiply these two, it is a 0.052. Do you know? You know how to do that, right? You should understand. If you cannot follow, then check previous part. Then now we are going to calculate probability B. How do you do that? Using this, and then you have to have a probability A complement times probability B given A complement, and multiply these two. Then you get the probability A complement intersection B. Then add probability A and B plus probability A complement intersection B. Then you can get probability 0.259. Then probability A intersection B 0.052 divided by 0.259 is equal to 0.201. The probability of scoring 650 or better double to 20.1% when the prep course is taken. So what is his decision? He's going to take prep course. That's how to calculate. So in the base law we use a lot of probability rules, addition rule, multiplication rule, and also complement rule. It includes everything, right? So it's a very good problem and used a lot in real world problem too. So please, you should fully understand this technique. Okay? Now let's see some Bayesian terminology. The probability A and probability A complement are called prior probability because they are determined prior to the decision about taking preparatory course. The conditional probability, probability A given B, is called posterior probability or revised probability because the prior probability is revised after decision about taking pre-course. So here I explain what is prior distribution, prior probability and posterior probability. Okay, up to now we learned addition rule and we draw probability 3. It's easy to apply probability rules. And then we learn the Bayes law. Using prior probability and likely probability, then using these two, we can calculate the posterior probability. Then next, we are going to learn random variable and discrete probability distribution. Before next topic, we are going to take a 10-minute break or 15-minute break. Take a rest and then see you next topic.